Okay. Um, okay, so don't know if everybody can see me on the screen. Yeah, so if somebody is not able to see me, just let me know. We just started the lecture. I think I've also started the recording. Um, okay, okay. Hi everyone. So welcome to the second lecture. I see quite a reduced number of students, but okay. So I thought I'll take a few minutes, the initial part of this lecture, to just revisit lecture one because I uh, organized the content a little bit better, I believe, on the course page. So, can everybody see the course page? Can somebody just type on the chat saying yes, perhaps? Okay, thank you so much. So, what I did is just reorganize, and I wanted to get over a couple of logistics as well today. Um, so, mm, yeah. So as you can see, I've made separate sections for lectures. And before that, I wanted to look at the logistics. I've added the schedule under logistics this time. Um, and I guess the new thing is about the project. So I want to get started with that. And then I'm going to look at, revisit some things in lecture one. And then we will get to lecture two's aims and lecture two's objectives, as well as get started with the lecture two's main content. So um, so I would suggest students to have a look at this project page, which describes what is expected from the project. So I've made this course. I mean, this time I made it a project-focused course because I think many of these lectures are not really intended to just listen or just use pen and paper and so on. So you really want to get your hands dirty. So it's a little bit more lab focused. So I think the project is a great way to try out a subset of technologies that we'll see in various lectures in this course, and document your experience working with them. So um, I guess in terms of logistics, the important part is you should form groups of 4. So I would suggest try to form as soon as possible, and you can use a Slack to figure out this group. Okay, because the project is a big component, there are aspects where you want to kind of plan your work so that there's a good share of workload across the team members. Now, in terms of deliverables themselves, there's one due date basically for the exact date. Look at the course, course logistics main page, and essentially you need to produce a project report, and of course the associated artifacts like code and if there is any data needed, and a video presentation. Uh, Basically a 10-minute video presentation where you walk through some highlights of your work. You as in the team highlights some of the things that you did, and you should upload it to Blackboard. I have not set up the page yet, but I will. I will set up the Blackboard project page soon. Uh, Sorry, I'm just trying to reply to a student. Okay, so let's get back. So somebody asked how many students. It's 4, and you should reach. I mean, I just said you should reach out to to your classmates. Because it's a group project, commensurate effort is expected, especially across team members, and you want to kind of mention that effort as well in your report. So, uh, is there any questions about the project? So that's actually the majority of the logistical things I wanted to mention today. Um, so somebody says last week 4 to 5 established a group of 5. So group of 5 folks, I think you can just reach out to me on Slack separately, but I strongly suggest 4. I mean, if people are trying to make groups, I would suggest definitely 4. So the 5 folks, you have to reach out to me. Next, let me get to so that's the logistics and a little bit of reorg of the content. Now, I think there was a part where so. Is there any questions about project other than groups? I think a couple of folks have mentioned on the chat. Group sizes, sorry. Is there any question about anything else about the project? I think it'll figure out. I think it'll take some time for you guys to, definitely go through the project deliverable document, essentially instructions. It's not. It's basically an exploration by you guys on some machine learning deployment techniques and sort related, data science and analytics workflows and technologies, right? So there are many interesting new things coming up, especially for machine learning deployment. So and I gave an example in that in that instructions page, but it's a good chance for you to learn something which is immediately applicable. Really, I mean, you've been learning a lot about model development, model A versus model B, all sorts of diagnostics of model in offline data. But I think this what you do through the project will help you in your day-to-day work, potentially. So with that, what I wanted to spend time on first is lecture 1. I reorganized the content because the last time there was some comment about uh, the commands that I'm using. So I try to document as many as possible. Certainly, you have the video lecture available to you to have a look at it. So last time we looked at, so I'm going to do a quick recap and show you some new changes, which we did not cover last time. One is, so this is what we went through last time. So which is we spinned up a virtual private machine, a virtual private server on a vendor, and we set up I don't we set up SSH access to it, and then we dove into a Conda-based environment creation and Conda-based package installation. And then we installed Jupyter and also configured Jupyter a little bit. We installed, so in the sense like we set up a password for Jupyter, for example, and we also figured out how to tunnel to that Jupyter server so that, if it's a beefy server, let's say it has a GPU, for example, then you can open and start a kernel remotely and run your deep learning training, for example. Then we also saw how to make requests to web endpoints, essentially using request package, request module in Python, and also how to parse the response. Once you get a response object, then you can look into the JSON, field or the text field and so on. Then we briefly touched upon model persistence, where we said that the biggest concern is basically if you train a model on Python 3.8 and on Mac, does let's say you train the model and you dump the model into disk, and then you take it and some other team member and some other group takes a model and deploys it on a Linux machine which has Python 3.7.6 or something, then would your model still have will it be read back properly, and what would you face any issues? And one partial solution to that was with MLflow, which kind of uh, deals with this inconsistency in environments. And today I'll comment about something that I came across when I was building a couple of machine learning models for our lecture 2. And finally, we also looked at how to serve a model using the Flask web framework. It's a developmental framework. So we saw how to instantiate a Flask app. And the cool thing about Flask and these types of technologies was that your web endpoint can be mapped to a function, and essentially all the action happens in the function, where you can process a request, a GET request or a POST request, and see what's being asked. Typically, it's the input for your prediction model, and then you can create a JSON object, for example, of a prediction or predictions, and send it back. So that's what we saw, and we deployed it on the server, on the remote server that we created. So that's what we did. So what I've done is, so in terms of, you look at the bullet points here on this page on lecture 1, we looked at basics, SSH and firewall, in the last lecture, setting up Python remote Jupyter server as well. What's new and new from last time is that last time I was using a couple of other prediction models that I was using to demonstrate serving machine learning models on web servers. But today I'll be using a recommendation system example. Okay, so I thought I'll move that model as the canonical model for both lecture 1 and lecture 2, in the sense that if you try out lecture 1, I would suggest try to use the models described in the recommendation in this subheading on that page. And so serving ML models using web servers and Flask app, we have seen that before. Instead of the Echo app, I think I also show a different service instead of a model server, instead of a Echo Flask example, where whatever is in the request, if there's a message, you just reply back with the same message. I show here how to have a simple weather reporting service. It's actually a redundant service because it's just reading weather information from the National Weather Service and just forwarding that information to you. So you can look at this particular Flask app example. So all you have to do is have Flask installed on your environment on the on the server, and then you can actually run this Flask app. So the biggest thing happening is, as I said, you are able to Flask lets you map the route to a function, and here the function is essentially using two additional modules. One is so actually just one additional module. Okay, actually two. Request as well as GUI. So request is what you would use to interact with an API within a web server. But I'm also going to use request to request another API to give me some information. So that's actually two extra things. One is, so the way we report service. So the objective of this app is to give back to you, all data about the weather and, let's say, Chicago. So you can do that by doing two things. One is get the name, get something like a message with let's say the name of your location, like Chicago or Los Angeles or something like that. And then I'm using the geolocator, the geocoding function to get the lat long from that, from the city or place name. And then once I get the lat long, I'm just doing a request, which is again a GET request to the National Weather Service API with the location latitude and location longitude. And then I'm dumping. Once I get the response, I'm just giving it back to the end user. Okay. So that's the example. So it's a little bit more elaborate than just replying back the message. So here you could have just said, instead of doing all this params message, you could have replied back in JSON, or here itself. Instead of data.response, the response field of this dictionary, you could have just made it params message, but instead of that, I just changed it. So that's the app. And in terms of model serving, the code here is with respect to the models I'm going to talk about next, okay, which is recommendation models. it's a little bit of a breather between machine learning deployment to spend a little bit more time on models. So I'm going this is essentially a usual Flask app, except we're going to recommend a movie. So let's go to the recommendation models. So it's just a canonical model. It doesn't have a recommendation model. Last time we spoke about a couple of arbitrary generic prediction models. So this time I thought I'll just fix the prediction models to be recommendation models, um, and, uh, and that's what we'll kind of try to work with in today's lecture. So let me describe a little bit more about the recommendation models. So the first model, so we're gonna use a very classical data set here. It's the movie lens data from Group Lens organization, I think. So we're gonna look at, so movie lens data set is essentially a data set of users who have rated a bunch of movies. Okay, so essentially the data looks like user ID, item ID, which is the movie ID, and the rating. There's also user-specific information like their gender and occupation. I think there's also movie-specific information like the movie name, the genre, and so on. But that's the lowest, that's the smallest data that you can pick up from there is essentially which users, which movies, what rating did they provide. This type of data is actually quite rare in the sense of explicit. So although in the sense of explicit rating systems are relatively sparser than implicit rating systems. Explicit ratings means somebody gives a feedback on a movie saying this movie is really good, this movie is really bad. Um, implicit feedback systems just log passively what the user is doing. Maybe the user spent more time on the movie, maybe the user completed that movie, which kind of expresses an implicit preference for that movie. Okay, so most recommendation systems these days are, I think, focused on the implicit feedback idea, whereas the original Netflix prize and so on were more focused on the explicit feedback idea. But the movie lens data that we'll look at is essentially explicit feedback. So, so I'm actually not going to go into the details of. So I gave you a sense of the data. In terms of the modeling techniques, we'll not really spend too much time on. But what we'll do is two things. One is to build a model in one type of package, and second is build another type of package, build another type of package. So the first package we'll use is a package called Surprise. It's just a a convenient Python module available to play with various recommendation system models. So we picked that up, and then the second one is to explicitly code down your neural network style code base for doing the same thing, okay, which is to build a recommendation engine. So let me just walk through the so let me just walk through this and then I'll get to actual hands-on stuff. So if you look at this code base, it's pretty small because we're just using demonstration style data. In actual work, you will spend like 90% of the time on just getting the data set in the right format. So here we're just picking a simple algorithm, which is a variant of SVD, and we're getting the accuracy. We're measuring the accuracy using root mean square error, which is just which is just the how off our predicted ratings compared to the true ratings for that user in that movie. So for example, you could imagine your training data, you split it into two parts, where a part which you don't use for your training is going to have a user item and the actual rating they provided, and you're going to just once you predict for this user and the same item some number, you're going to compare that predicted number to the true number. You can use RMSE as a metric there. And I'm also going to use a function that's provided in this module to dump the model to disk. So you just read the model, read the data, and it's very similar to scikit-learn interface. You just do algorithm.fit or model.fit, and predictions you can get by algorithm.test, and that's it. And then you can also, if you want to give predictions to users, you actually want to not predict. So basically, you want to predict ratings for those movies which this user has not seen. right? And so that is captured, that you can get by using a function called here in this particular package, but that's fine. So what I'm trying to say is that for a user, the movies that they have not seen, you can make predictions. And that's what you can store in an object like predictions, and maybe you can use that later on for your for serving a prediction model online. Okay. Uh, so if you look at the, so that's training. So you trained a model and you got these predictions, and you also have a trained model here, algorithm. So you can dump both the algo object and the predictions object to disk. That's what is happening in the last line here. Um, and then once you've dumped those to disk, you can actually, I mean, again, I'm importing a few modules here, but let's directly see what's happening. So I'm just going to read the predictions and algo from the local file that I created. And then I'm also reading a metadata file, which is the names of the movies, because I don't want to just recommend the movie IDs, but you want to map it back to the movie names and then um, uh, show and then make the recommendations. For example, so what I'm doing is actually in this at least offline script, which is a little bit inefficient in hindsight, is that we're actually getting the top K or top 5 predictions for every user. So there's actually about 900 users or something here. So we're just dumping out all the top 5 predictions for each user. And because it's an offline file, offline, I guess, development, we're just showing, oh, for each user, what is the, print the user ID and just tell me what is the movies that I've already watched. Some example, maybe only 10 of them, and then show me the recommendations that you're giving. So I am not a movie buff, so if somebody in the audience is a movie buff, you can look at and play with the script and interpret this. For example, user 196, they saw these bunch of movies, and they saw more probably, but I'm only printing 10. And these are the top 5 recommendations that are being given to that person. So this is completely, this is the inference part, okay, for the same model. Similarly for PyTorch, I wanted to keep the data set creation the same, so that's why I imported the surprise library here as well. I don't think I need dump here, but I just use that to get to the data set part. But mostly what we'll do is build a torch based model description. So there's a bunch of helper files. It's basically how to load the data, and this is actually the key thing. This is the model where you're saying how many users are there, how many items are there, and this is actually collaborative filtering. So you have to determine how much is the latent space dimension that you want to pick. Here's some number 10, 18, and a bunch of additional a bunch of additional parameters that you can use. Okay, so those parameters are basically how much do you weigh. I think how much do you weigh the bias of the user and the yeah. So it's just the parameters corresponding to the regularization aspect. Okay, so the regularization part. So I'm not gonna slow down a bit. Okay, so actually the model building is not our objective. So if you've not done deep learning, don't worry about this PyTorch stuff, right? So one thing that should be clear is that there is a model, right? I mean, so this is probably arguably one of the smallest scripts for training a data, right? So this is using some existing library. You could use scikit-learn thing. So here's a couple of lines to import the data, a couple of lines to fit it, and a couple of lines to tell me how good the predictions are. And then I'm just dumping the predictions to disk. Okay, so that is where we start, right? This whole course is like, okay, you already built a model. Now, how do you serve it? In the last lecture, we were spending a lot of time on using Flask based, our own server and a Flask-based technology to serve this model. Not this model. So last time we saw serving a simple multi-class classifier. So here I was just grounding it into a more specific application. Now somebody asked a question, what do you mean by the bias of the user? So so if you go to that the PyTorch example, there is, so don't worry about the model specifically, but there is aspect of the model which captures user bias and item bias. It just means that, for example, for some users may be predisposed to giving high rating to everything. Okay, first, so for example, they'll only give ratings 5 and 4. Okay, for them the bad movie is 4, the best movie is 5. For somebody else, the best movie is 3 and the worst movie is 0. So there is a mismatch between the mean ratings that this person is giving and the other person is giving. So you can actually balance that out by having an additional modeling term which captures user bias. Okay, so that's the question about that. Yeah. So I think so definitely let me know if I know you said slow down a little bit, but since I'm just recapping last lecture, but this part is kind of new. But I don't want to spend too much time on the model descriptions themselves, the details of the models. At the end of the day, we have a model on disk. Okay, we are a data scientist or a business analyst. We created a model, right? In this case, a recommendation system model, and we dump it into disk, right? And so once you dump it into disk, you can use another script, right? I mean, this is another script which is just reading, the dump model especially, and a few other metadata things to do some recommendations. So this is just a internal check for you, right? Now, what we did last week was to move these two scripts, or at least the inference script, this particular script, into a Flask framework. So it's not very difficult to do that. Once you have this going, once you know how to make predictions, then you can somehow insert this into the Flask app architecture, right? And so the request can be a user ID, and the response can be a bunch of recommendations for them based on our pre-computed predictions or pre-computed model. Okay, so that's what we wanted to do last time, and we did that not for recommendations, but for a couple of other previous multi-class classifiers. Right. So here I just wanted to show you to do the same thing, same data, the movie lens 100K data, which has users, items, and their ratings, and a few other things, but we care about users, items, and ratings. And one model was essentially an SVD variant, and the other model is also essentially an SVD variant, but it has a little bit more, which is the user bias that somebody asked here. Okay. So in terms of slowing down, I will not really spend time on these functions, because I think we should spend a lot more time on deployment. But I'm happy to spend more time on this if we can finish up our deployment. So today's lecture is about serverless deployment. So if we can do that, then we can come back here. So all I wanted to show was that there are a bunch of classes here, functions. So that's not the critical part. But to keep the data same, I just had to use the surprise library again. But and I also used something called ignite, so which keeps the the whole operation, whole training operation small. So you have a bunch of parameters here, and once you initialize the model, then and define. So because now this is more custom, you have to define what is the optimization technique you're going to use and what metrics, and then you have to just call trainer.run. Okay, so the in between things are just ways for the training loop to access the data. So that's why there's something called loaders and so on. So once you get into PyTorch, for example, in the 576 course, we spend some time on PyTorch based CNN models, text models, and so on. There we'll see data loaders, data sets, objects, and so on. Okay. So, but here for us, all I'm saying is there's a easy way to, somebody developing a recommendation system based on Python, using Python and PyTorch can do some script like this, okay, and see some performance. Maybe here there's some mean square error of 1 unit. I think this is actually quite bad. So mean square error of 1 unit means I'm off in terms of rating by 1 unit. Okay, the rating scale is 0 to 5. So if the true rating is 4, maybe I'm guessing 3 on average, or something like that. Okay. So this is lower the better. So, but at the end of the day, you build that model, you do the training phase, and then you dump the model to disk. Okay, so which if you use PyTorch, then you use torch.save and do this. Okay, and if you do this, then you can literally read the same model. So again, this is literally this this class is essentially the model description. It's copied from the previous um, page. So you just have to read the model. So here's, okay, let's start with this cell. So we just, so what is the model? And then model.load. Okay, load the model, and load the model. If it's a PyTorch or neural network based model, all you're dumping to disk is weights. So you have to just read the weights and insert that weights into the model description. And then you can start evaluating. You can show the recommendations by this model. And you can see that for, let's say user 196, the recommendations are different, I guess. What is this? I believe they're different. Yeah, it's Richie Rich for this person, from the model A, and the PyTorch model is predicting something else. I mean, recommending something else. Final insult, or other things. So those are the two models. For us, I think we just need to pick up these two models and figure out how to deploy. And last week was all about how to deploy these models using Flask. So this week will be about how to use some cloud-based techniques to do the same. Okay. So I think when we go through this lecture, maybe we'll revisit some of the ideas about the model and things. So if I was too fast about the model part, don't worry. We'll have some time to parse the model, because we'll probably be reusing the model again and again. These models again and again. Any questions so far about the recap on lecture 1? There was one more part about model persistence, which is where I said if the environments are different, you can use something like MLflow instead of like using PyTorch, torch.load and torch.save, or scikit-learn dot load and save or something like that. You can use MLflow as a way to deal with environment variations like Python 3.8 versus 3.7 and so on. Okay. So I'm just checking if anybody has a question. Okay, so there may be maybe questions will come up and you can ask on the chat. So here's so I just added a exercise I guess page where I'm just saying that last time we used Vultr as a VPS provider to deploy the Flask server, but that required us to do everything, right? We had to start the instance, set up the Git, or not Git, but set up Python completely from scratch, and then run the Flask server. So you can also, so Heroku is an example of a provider which is a platform as a service where you have to do a little bit lesser work to get your app running, and they have a free tier, so you can try to do that. You can also try setting up a custom domain to point to your virtual private server. So many of the data science projects that you're doing, you can actually dump them on Heroku and provide a custom domain, or on a virtual server like EC2, and put a custom domain in front, and you can show that as a portfolio of your projects, right? You can repeat the setup on AWS, Google Cloud, or which is what we're going to see today, or DigitalOcean, or any other choice. You should look at the documentation for Flask and other things that we've used. Surprise is new today. You can also replace Flask with other web frameworks. I mean, I've just mentioned Python-based ones. Django is quite popular, as well as a few things like Starlet. There's also something called Fast API that you can try. And one final thing you can look up is something about function decorator. So if you look at the Flask app, there's this magic command @app.route, right? So this is an example of a function decorator. So you should so function decorators, what they do is they take in the function below them. Sorry, taking the function below them, which is from here to here, and spit out some additional, add something to that function, and then work with that. Okay, so function decorators, think of them as wrappers for the original functions. This is the original function, and because of this function decorator, it becomes a new function. We don't see it, but it becomes a new function when it interacts with the HTTP request. Okay, so let's so if that's good, then maybe we'll start with uh, lecture 2. So today's objective is actually just serverless deployment. So we already have some models, the recommendation system models, and we will try to use Google Cloud and AWS to serve those models, okay, and in a managed way. And so with that, let me start with what is serverless deployments. Okay, so today's theme is all about serverless techniques. Okay, so at the end of today's session, you basically want to kind of be able to understand. You should be able to understand what is the advantage, pros and cons of a serverless technology. When can you use it, and also how to use it with two popular providers, GCP and AWS. So let's look at what the problem is. Problem is if you have a machine learning model, you're a data scientist, or your team is fully business analysts and so on, but you want to expose some model that you built to folks internally or externally, then you have to do something. You have to do a DevOps yourself. By DevOps, I mean you need to spin up a server, which is what some of what we did last week was essentially DevOps. Right? So we have to take care of provisioning and maintaining a server. For example, we serve a model from a VPS. What if we have to update the model? Can we turn off the VPS? During that time, will users face issues? Do users expect the model to be always there? And what is the latency of serving that model? Like what is the backup plan? So and also there's a question of scale, right? So if you want to expose your API, maybe it's the part of a app that you built and you launched it on the Play Store, then or the App Store. Then if you have suddenly 1 million users using your app, and if they're all hitting your servers, maybe you'll not be able to. Your model may not be able to serve them, just because of resource constraints. So, and also there's a aspect which is that you want to minimize time to deploy your model. Then this whole DevOps thing that you would go through on a hosted solution, which is you figure out a server, install all the software in it, and then set up a web server. So that's going to take time. But if you can do it without doing all that, then maybe there's even if there's a little cost increase in this strategy, then maybe you will consider it. And finally, how can a single developer manage a complex service? One of the ways is to be serverless. Basically, you're not worried about backups, reliability, scaling, and many other things. So that's the problem. The TLDR is that, and the solution is use software and services that abstract away server details. So you don't need to know what OS it's running on. You just need to know the runtime and where are the files that you need to serve. I mean, files as if you had model files. If you just know the runtime and where your models are, you can use them to make predictions, right? You don't need to know how the is it 1 machine or 10 machines, and what operating system it is, and so on, right? And the software also automates, essentially behind the scenes, it automates provisioning of servers and scaling machines up and down depending on your use case, right? And it also does what is called load balancing, so where you balance the incoming HTTP or whatever type of requests, so that not one server is not overloaded compared to another server, right? So maybe you have 2 servers with the same prediction model, maybe one in Chicago, the other one in Los Angeles or something, and then the server in Chicago is getting overloaded. So there's a way to balance the incoming requests so that things don't get overloaded and stop working. So that can all be done behind the scene. So as I said, we just have to specify the runtime, which means specify our requirements. We'll assume that we're working in Python. So our requirements could be things like having pandas, PyTorch in the runtime, right? So that's the objective of a managed solution or a serverless deployment. That's the problem. That's the solution that we are going to come up with. So what's our objective for today's session is to write serverless functions that generate predictions when they're triggered by HTTP requests, and that's what we'll try to do. And we'll work with AWS and GCP, and we will deploy not a Keras or an SQLine model. We'll we'll deploy the recommendation models that we discussed earlier. And it turns out there are some if you really you don't sometimes have to load the model itself. You can just put the predictions on disk and just serve them directly. Okay, in that case, you're not really working with the model itself. You're working with the predictions. So we'll see that. So let me spend a little bit more time on managed services. So serverless technology is an example of a managed service. And cloud is all about managed services mostly. So the cloud abstracts away a lot of things, right? On AWS, some of you tried AWS over the past week. You saw different sections like compute, storage, networking, and various things. So it abstracts away various computing components, which is, it's like your computer, but many of the things are abstracted away and managed by others. Okay, in this case, AWS. And so managed services also minimize, thinking about dev staging versus production and the issues that surround these things. And in particular, in this point, I'm talking about serverless technologies. Okay, so in serverless technologies, it's very easy to switch from dev or staging to production, because you don't really are managing the environments. You're agnostic to the hardware aspects and so on. Right? And here I'm just pointing out that what we did last class is essentially a hosted deployment, so the opposite of a serverless solution. Sorry, the serverless techniques were kind of introduced to the public in 2015-16 by AWS and GCP, Google Cloud, and it just contrasts with their previous offerings, which were mostly they just were infrastructure as services companies. So basically, you could just rent EC2 and I think some of you have tried working with EC2 earlier this week. So one caveat before we get into our first serverless example is sometimes managed solution is a bad idea. Okay, so when is it a bad idea? When it's a bad idea when you don't need quick iteration. So like you'll see, for example, that we can very quickly create and delete model deployment functions. Whereas if you don't need such a speed, then maybe you don't, maybe there's a bunch of processes and protocols that need to be followed for model deployment, then it's managed solutions is probably not a good idea. And you also need a high-speed service. So, okay, somebody asked what is the difference between hosted and managed. Hosted means what we did last week, and managed means somebody else managing the underlying, behind the scenes stuff. So serverless is an example of a managed service. Like for example, there are companies which will manage databases for you. For example, MongoDB is a managed service. You don't have to know all sorts of issues about where is the database, which server, is it a Linux machine or and details like that. Right? You just need to access the database. Similarly, hosted just means you can host it on premises or data centers. You do a lot of the work, and you can also do it on AWS as well if you use EC2 and set up an infrastructure yourself. Okay, so that's all hosted means. So AWS EC2 would be considered serverless. No, EC2 would be an example of a compute. So EC2 would be the equivalent of a virtual private server. So last time, remember, we created an instance which had, I don't know, 1 GB of RAM and 20 GB of hard disk and so on. So EC2 would be an instance of that. It's a virtual private server. And for our projects, we have to do serverless deployment or hosted. So, okay, so your projects, it's totally up to you. I mean, so your projects have to be related to some technologies introduced in this class. So you can look at, so far we only looked at hosted, techniques last time, which was just web server deployment. And this time we'll look at a couple of serverless examples. But you are free to do many other things. There's going to be many other interesting things coming up later. For example, next class, we're going to look at containers to deploy machine learning models. So you can work with containers if you want in your project. So one more question here. Uh, so anything where SSHing is considered hosted. So okay, so actually the objective of this class is not define, in a very crisp way what is hosted and what is managed. So SSH would be like you're managing it yourself, right? So since you're managing it yourself, it's not really a managed service. So I mean, if you're managing the end machine, the cloud machine, for example, like an EC2 machine or something, or VC2 or the VPS. So in that sense, you would consider it as a hosted deployment. Yes. So for example, the Jupyter Notebook setup that I did on a remote machine, that would be essentially a hosted deployment of my work, or essentially, yeah, that's what I would call it. But these are just some people may call it, the boundaries may shift depending on what you think is managed and what is like not really managed and you are doing it. Yeah. So let me finish this page with a couple of more points on when is managed solution a bad idea. When you don't need to scale your system arbitrarily. If you're only deploying a prediction model internally for some reporting and dashboarding in your company, then the number of users maybe is less than 100 or even 50. Then you don't need you just need a fixed system. You don't need scaling arbitrary scaling aspects. So that way you don't really need a serverless solution there. And you also have, for example, you already have in-house teams which can do DevOps, and in that situation also you may consider not going with serverless technology, because they come with a little bit more higher cost because somebody else is managing the systems for you. Okay. So with that, let's actually start jumping into Google Cloud. Um, Okay, so from now onwards, we're going to actually try to uh, follow, so I have screenshots of what to do. I'm also trying to do it in real time because that hopefully will slow me down. Um, and also, that's I think what we did last time. So let's try it out with this. So um, first part will be using Google Cloud. In Google Cloud, the service is called Cloud Functions, and in AWS it's called Lambda Functions. Okay, so we'll first work with Cloud Functions. So Cloud Functions, basically, as you know, as I've been telling, you need very little boilerplate beyond just knowing the runtime where your Python function needs to run, and and uh, um, and the requirements, like the packages that you need, for example, like pandas or something like that. So beyond that, you don't really need much to deploy your machine learning model. So, um, but there's also one more aspect. So packages is what I said, the runtime. And the second thing is where is the model stored? So for example, you dump the model using Pickle. Okay, Pickle is a way to dump serialized objects onto disk, like dictionaries, lists, as well as some models. So once you put it on a disk, it's on your hard disk. But if you want to put it on AWS, or in this case Google Cloud, you want to put it on Google Cloud's infrastructure, and we'll see how to do that. We'll use the Google storage to Google Cloud storage to put the model onto their infrastructure, so that we can read it from there. Okay. So first we will set up a uh, you know like we'll just go through the motions of setting up a cloud function without really working with the machine learning aspect at all. And then we'll set up triggers that will trigger this function. So in particular, we just need to define, okay, when will this function get triggered, right? So when a HTTP request comes at a URL, it'll come with some information, and that should set the function to start computing, right? Computing the output given that input. So uh, so so let's go over that. So let's start with, so I would suggest sign up with GCP if you have not done so after this lecture. But yeah, so this is the GCP interface. Um, Let me actually put this separately. Um, I'm just separating it out so that I don't switch between the tabs too often. So everybody can see my screen. I'll just say this. Sorry. Can see my screen for GCP, right? If you're not seeing it, let me know. Okay, good. So let me, one more thing here. Okay, setting up cloud function, trying out cloud functions is not difficult. So let's go to the console. Okay, so let me, oh, yeah. So, okay, let's just do that. So cloud. Okay, so let's pick up. So I just use the search bar at the top to uh, pick up the cloud function feature, and then so you have a very simple GUI to actually deploy a function. So let's deploy a like a hello world function first. So let's do create function, and so it's asking what's the function name. That's a function one, some in some region, and in particular with HTTP, we want to trigger it with a HTTP request, and we'll eventually use this URL. So for now, we'll actually do allow an unauthenticated invocation. So this is actually probably not a good idea unless you do additional work. But for now, for demonstration and for just development work, you can do this. Unauthenticated just means that anybody can access that URL, right? So maybe we can copy this URL somewhere. Okay, so that's fine. So let's save it, and okay, let's go into next. And this is the kind of the important, I guess, the central piece. So we can change the runtime. So here you can see many runtimes that are available. So we're going to use Python. So let's use Python 3.7. And here is an example function. So hello world, all it's doing is, so if you look at, so there are two files here on the left-hand side, and there's a code that you can edit directly on the right-hand side. So the entry point is, so its runtime is 3.7, sorry, runtime is Python 3.7. And let's say hello world is the entry point. It's just the name of the function that should accept a request. So similar to Flask, remember in Flask, there was a Flask.params that was getting set with the get request or post request related items. For example, if it was the if it's the weather service and I ask for the weather of Chicago, then the Chicago is the string is available through flask.params, for example. Right? So so here flask.request essentially. So this is essentially Flask app. So so we have this request as the input, and then all it's picking up is the JSON part of this input, which will have the fields that you care about for processing. Okay. So in particular, this is actually, since it's accepting JSON, it's assuming the payload is in JSON. So the previous lecture, the last lectures, in the last lecture, we were not creating a JSON payload. It was just a command. It was just a get request. So here we have to make essentially a different, like we'll have to attach a JSON payload. Okay. So it's just saying if the message is in requested args, then you just return that message. Okay. So let's see. Yeah. Yeah. So okay. So that was the first file, which is the main.py file, and as I said, entry point and the function definition should match. And the next part is the requirements files. For that function, we didn't really need anything, any package. For example, what you can imagine here to having NumPy, pandas if needed, and so on. Okay. So actually, let's do that. So let's actually run the weather service. Okay, so for weather service, if you look at my that web page that I'm looking at for cloud functions, you can see I have a uh, once you get to the screen, I have a example weather service function there. So let me start with requirements. So the weather service requires three things: Flask, GeoPy, and requests. Maybe Flask is not needed. I'll have to check. So this is one module, and this is another module that we need. And if you go to Hello World, so let me somehow the function here is not well indented. Sorry, so I'll have to do something. So okay, okay, this is good. So in the function, just importing Flask. So I'm importing JSONify to create a JSON object at the end of the day. I mean, that's the response I need to give. So I'm importing the usual things, creating a dictionary called data, and that's what I'm going to return at the end of the function execution. So initially success is false. Success is the key for which the value is false. Creating the geolocator object, and then I'm getting the get JSON, right? So previously there was this, we were not doing this explicitly, but this time with the cloud functions, we'll have to use get JSON here. And we're checking if there's a message in parameters. If there's a message, then that message should be the location information. And so we're going to figure out from location the location's latitude and longitude. That's what's happening in line 11. And then once we get the location, and you can look at these URLs to figure out how the API works. But sorry. Yeah. And then in line, so once we get the location, in line 14, we are making, so we have to make a get request to another API. Okay, so another service. Okay, so that service is National Weather Service, and we are just passing on location latitude and location longitude. Okay, and from there we get a result. So this request to the weather service requires two requests essentially. So first is to get from location from first request we get essentially a grid point, and from that grid point we can get the actual forecast. Okay, so it's just how their API service works. So we do these two requests, and whatever result we get, we're dumping that into data response, and we're just changing the success, from the field from false to true, and returning the object back, okay, as a JSON object. So that's all there is to it. That's all there is to it to deploy this weather service example. So let's run. Okay, we'll have to change the entry point to weather, and I think that's. Oh yeah, somebody actually pointed that out. Great. So yeah, weather is entry point. No, there's no multiple entry points. There's only one. Actually, you see that the serverless technologies have their own limitations. So you can't really have very bulky like functions. For example, if you develop a huge prediction model which still relies on pandas, scipy, numpy, and 100 different modules, then loading all the modules on cloud functions is easy, but on AWS Lambda is difficult. But yeah, the entry point should be weather. So let's deploy it. And so it will take some time. Okay, for this, the memory allocation is fine. So I think for the next, for when we deploy the ML model, I think I probably have to change the memory allocation to a higher number. So let's see. So any questions in between? There are many participants, so if somebody's not following, definitely ask questions here, and I'll definitely try to answer. So let's see how, once we deploy that, we can take a break. And Which ones do I prefer? Actually, I have to say I'm also relatively newbie here. I was mostly into the hosted way of doing things, but then uh, as I've been working with folks both in the industry, mostly in the industry and academia, it makes sense to use many of these managed services. For example, it's a very different example, but from machine learning model development on big data, as I was talking about in the first lecture, if you have really large amounts of data in SQL tables and so on, then a managed service like Databricks, which essentially is a wrapper around Apache Spark to do ETL jobs like doing data cleaning, data preparation for machine learning model, is an example that you should try to use. Databricks is the managed service vendor here. Uh, so there's always a pro and con. You can always set up a Spark cluster yourself from EC2 instances and do it, but maybe it takes more effort. How are you charged for using cloud functions by number of hits? Yes, so billing is something I did not discuss. It's basically the number of hits. Yeah, that's a great question. It's not, so there's no server running here. So, and that comes back to the latency aspect. So, so every time you get a request, you have to start from scratch. And so that may add to your latency if you don't prefer that. Okay. Um, and maybe we'll talk about latency when we build the machine ML model. So let's actually go to test function. Yeah, since this is a weather app, so the trigger event, okay, trigger event is, so we have to create a JSON file, sorry, JSON payload. So let's do this, and that's pretty much it. So let's try. Okay, so we did get a response. It was not a bad response, I think. So it's a huge response. So it'll give you a lot of information. So the National Weather Service gives a lot of information. But somewhere in there is, I think in properties, there is going to be temperature for different periods. So period, I think 0. Okay, so period. Yeah, there's some, as you can see here, there's a forecast, but I'm trying to see. Okay. Yeah, so period 1, I guess. So there are different periods, and each period has its. So this is probably not the best interface to look at the output, but and actually I can post. I mean, I'm just dumping the National Weather Service output, but you can actually post process it and get to the right. It's a JSON object, so it's essentially a dictionary. So you can get to the right temperature, and you just report back the temperature if you want, or the text, right? And it actually gives, I think, 7-day forecast, so you can get all future forecasts. So the function works. So. That's good. So if you go back now, yeah. So actually, the interesting thing is you can just uh, get the URL. So I think you can just um, so if I go to the function, uh, yeah, the service account. Oh, not service account. Oh, there was a runtime. Oh, there was an error. No, there was an error. Uh, okay, I don't know if that error is today or not, but okay. Maybe there's no. Okay, let's see. Okay, let's actually go to this. So you guys can access this. Let me post this in the chat box. Okay, the way to access it is not to directly get to that, because then you'll not get the. So you have to create a JSON payload. Let me see if I can create using. Okay, so let me share a different screen. It's called Postman. Okay, so can you see a different screen? It's called Postman. Skip the
Yes.
signing part. Oh, thanks. So let's screen sharing has stopped. Okay, let's do it again. Yeah. So let's create a request. Uh, see how to do it. Postman. I mean, we can do it using Jupyter, but um, okay, it's actually, sorry, I was trying to get to the, let me do a new uh, something. Uh, I don't know what is all these details. Uh, okay, I don't want to do this. I'm trying to figure out. Okay. Oh yeah, sorry, I wanted to get to this interface. So let's actually post that. So I think I gave you guys the URL, but let's see. Yeah, so that's the URL. And what we're going to do is we're going to do a JSON post, right? So I need to go to, let me go to body and do a raw and then choose JSON. So I think these instructions, maybe they're, so it's there in the lecture one somewhere, I think. So, uh, okay, so that's the uh, um, payload. And if we do that, error. Okay, okay, that is not. Oh, is our function not working? Um, oh, it is. Okay, let's actually. I mean, the test worked, right? Um, oh yeah, in the same web page, I have the instructions for Postman. Okay, so let's see. I just typed this somewhere. Um, okay, just switch back to here to just see if it is an issue here. Unknown error has occurred. Failure in the execution environment. Wow. Okay, so there is an issue with this. Okay, so it's not letting me test. Okay, so let's go back. Interesting. It's saying it's running, but it's not. I mean, you can always check the logs to see what the error is, but I think that will take time. Uh, okay, so let's do this. Let's take a break for 10 minutes, and in the meantime, I'll try to figure out what the error is or redeploy it. So after the break, what we'll try to do is set up the machine learning model here, and hopefully serve that. and then we'll get to AWS. Okay, so let's take a break. So it's 7:43. So 7:53, we can be back. Okay, so welcome back, everyone. So I deployed the same function again just to see what was going wrong. And with Postman, the issue was I was posting it as a GET request. I just needed to change it to POST request. So this is the URL. I mean, you don't need it, but I mean, you can try using it. Um, so here you can see, I mean, that's the URL. It's a POST request. So again, go to raw and change this to JSON, and you can give other cities. Um, work. I didn't check it. Uh, okay, it does, and you can actually look at inside the properties in periods. You can look at what is the in different periods is period number one, and you can see what the prediction is, and I think period two is tonight and has some specific weather predictions and so on. Okay, so is everybody fine with that part? Sorry, I'm trying to see the chat window. Okay. So does anybody have questions at this part? I mean, we just, it's as simple as changing the requirements file and uh, the Python function. Oh, what did I change in the Postman thing? I just changed, I mean, we didn't have to use Postman, we could have just used request. Basically, I had to change it from post to, sorry, from get to post, because we're posting a JSON payload. So it's a post request, not a get request. Yeah. Um, yeah, so let me get back to Cloud Functions. Right. So yeah, I deployed the same function again for I guess I can just delete them. Uh, oh, I mean, if people wanted to play with it, maybe we can play with the machine learning model. So now let's go back. So we covered how to make a request. So next, what we're going to do is yeah. So we want to say, so for the machine learning modeling, what we're going to do is first try to uh, um, save the model onto Google Cloud Storage, and then work with the model over there. And so for that, we'll need to install, I mean, we can actually do that manually through the user interface, but we'll first, we'll try to do it using command line. So so okay. So I am downloading the Google Cloud SDK, and it's asking installation directory. Sure, creating a lot of files. Um, so what we're trying to do is install the SDK and initialize the, initialize. So it's going to be a command line access to the Google Cloud services, so that we can create a service account, essentially an account which is not. So I just logged into Google through my Google account, right? Google Cloud. But we can create different accounts, and that comes into, I guess, the purview of identity and access management. So we're going to create a service account, which essentially means it's going to be programmatic access, and so different functions, different like I can use my Python to dump files into Google Cloud Storage and so on. So I think we help improve okay, I think it's just started installing, which will take some time. Okay, so yeah, so I was just laying out that first we're going to create a service account, and then we're going to use a service account to um, um, put the um, programmatically put a model file into the Google Cloud Storage. Okay, so on the cloud storage, there's this notion of buckets. So it's just it's like a folder, but it's not a folder. So we'll do that. Let's see, has it finished? In the meantime, if you have any questions, just ask on the chat or audio. By the way, Postman is a third-party tool. We didn't have to use that. We could have used Jupyter Notebook to do the same. Okay, so it just changed. So the G Cloud is available. Um, so source. I mean, wherever. So you just need the path to be set. I didn't want to restart the shell, so I just did this. Sourcing of the bash. So okay, there is some version numbers for these guys. So now let's do the. So init will do that one time. We'll create this. We'll make you go to a browser and enable this. I mean, basically you're logging in. So that browser activity I'm not showing because okay. So I've logged in using my Gmail account, and so I have a. So this is essentially the project, the cloud project within which we're working. So which project to use? We're going to use project one. So for you, the project name will be different. It's just a arbitrarily given name. So we initially we essentially logged in from the command line into Google Cloud services. So we're going to create a new service account. As I was saying, our service account is basically an account which is allows programs to access Google Cloud, okay, in particular Google Cloud Storage. So it's not a okay. Let's call it model user. Sorry, I'm just trying to create. So I'm going to run a command that that's there on the web page, but I just changed it to username being model user and some description and some display name. So it's going to create a service account to list this accounts, list all sorts of service accounts. I think I probably have to. So you can see from here that I have previously I created an account called ID service, but more importantly, I created an account. I mean, the name of the account is model user displayed, but so that's the account. Okay, so model user is the name of the user. This programmatic user. So why do you? So somebody asked, sorry, I missed this. Where did you change? Okay, why do you install SDK here? Okay, this is just an example to show how to use the command line to set up and push your model to the Google Cloud. Um, you don't need to use this. You can actually use the interface to set up a bucket on Google Cloud Services by just like how I searched for Cloud Functions. I can search for cloud storage and create a bucket, but I'm going to do it programmatically. And also, I'm creating in between. I'm creating a service account. A service account is an account which is not used by humans, can be used programmatically. Okay. It lets you do programmatic access, and programmatic access means through command lines, not command lines only, but through like within Python, for example, like in a Jupyter environment. Okay. So I created a service account called model user, and then I'm gonna add a. So this user needs access to Google Cloud. Google Cloud Storage, right? So I'm just going to make this person access everything in the project anyway. So this programmatic user access everything. So let me just change. So let me see, what was the list of the users I had? Okay. So I have the name is model-user. Okay. So now I'm gonna give this user a lot of permissions. Basically, his role is essentially role/owner. The member in this case is me as in the service account. So the name of the service account, the full, I guess, it comes with model-user at the project.iam. IAM means identity and access management. But it's just a command to say, oh, this service account can access various things in this project. Okay, and the project name is this authentic read something. Okay. Okay, so we updated the identity and access management project. Identity and access management policy for this project. Okay, so so once we do that, we can create, we can download a keys as the secret keys and so on. So basically, the secret key with which the programs can access the services, the Google Cloud services within this project. So I'm going to create a file called model-user.json. I'm going to dump it there. So when I run this command, essentially Google will dump a file called, I just called it model-user. Is project name the same as the service account name? No, the service account name here is model-user. So I think here you saw, so this is create model-user, and I just created the account first, and then I said gcloud projects, add the policy binding to this project, which is authentic-read something something. So this project name was given by by them arbitrarily. And then the service account is model-user. Okay, so member, you see member type is essentially service account. I hope that's clear. So service account name, it says a user like Teja at the project, or your name at project. Or here, since there's a programmatic access and it's not really a real user, I just said model-user. What language? So these are just things that you can run in Bash. So what we did is install gcloud. It's a command line utility, but you can install it on Windows, on Linux, on Mac, any of these OSs that you're working with. Essentially, gcloud is a utility which is searchable. So it puts itself on the path, on the executable path, like on Windows path, or you have this path variable, right? So that you can, on command line, you can just call gcloud space do something for me. In this case, I'm creating a service account, and then I'm uh, um, downloading the service account related access keys, like the permission keys. Um, that's what I'm going to run now, okay, which is going to create that JSON file. So, so the JSON file is here, and it's going to be useful for us. Okay. And then we're going to export that file so that programmatically we can access Google Cloud, in the sense that I can spin up a Jupyter machine, Jupyter instance notebook, and do that. So I'm just going to export this thing called the variable, the variable name, environment variable. This is called environment variable. I'm going to export that environment variable to locate the the service account's credentials. Okay, I think it's called. So that's my username actually. So just export that. That's fine. So let me uh, so actually there's one thing which I missed. So, okay, so the service account is done, credentials are done, but I want to show you how to access programmatically. So I want to um, I'm gonna search for um, so it's gonna be a little bit of a tangent here, but I need to install Miniconda and start Jupyter here. So let's see. I'm gonna do that on the command line, but give me. I'm picking up the link. So we had the Google, but I mean we have now the service account access credentials. It's just that this particular instance, I mean my machine doesn't have Python installed, so in the meantime, if you guys want to sign up for GCP or try something. Okay, while that installs, so to access Google Cloud programmatically, we'll also need to install one more package in Python environment. Remember last time I did I showed how to set up um, a Conda environment. So we'll do that and then install a key package, which is Google Cloud Storage. So this is basically a recap for you guys. So I installed.
So,
Uh,
Professor,
yeah.
so you did a similar thing last class to install the Miniconda for on the hosted thing, right? The
Yeah.
same thing you're doing it now on the
Locally,
cloud.
yeah.
Okay.
I mean, you can if you're on Mac or Linux, it's the same installation. On Windows, I mean, you can probably do that. I don't know. On the Miniconda page, does it say you can do it on the terminal? If not, you can just double click it and install it as well. It's the same thing.
Okay.
Yeah. I mean, I did it on a remote machine, but here I want to have local Jupyter access only to just programmatically access Google Cloud. I want to demonstrate that. That's why I'm doing this. I don't think. Okay. Um, so it did not change. Oh, dot microphone. Let me see. I need to do. So what I'm typing here is specific to Macs, just to get the Conda environment set up. I mean the Conda setup so that. So last time I did this, right? Data SI dev. I mean I just need Jupyter, and I also need another package, but I'll install it later. Maybe good. Yeah, I think this is enough. I think pip you probably get it by default. Wow, creating Conda environment takes time on my machine, I guess. Okay, install all these guys. Wow, just to install Jupyter, it's updating everything. It stopped. So I want to, as it's installing, I wanted to say that even on the AWS side, you can create a programmatic user through IAM service. Okay, so IAM is an identity and access management service. So you can build, if we have time today or maybe the next time, I'll show you how to create a similar to a service account. You can create a programmatic user account on that on AWS side and access AWS on command line as well. Okay. And these are very useful because once they're commands, you can actually programmatically create uh, S3 buckets, or in this case, Google Cloud Storage buckets, delete files, um, push, um, not just that, create and start EC2 servers, for example. You can do all that programmatic. Here, it's going to be Google Cloud Compute, but same idea. It's installing lots of things. Wow. I mean, it's generally not a good idea to install so many things. I need to use some more stricter requirements text or something. Um, anyway, it's taking a lot of time. Um, Okay, I think I should move on or change something if it's taking so much time. Uh, okay, so, okay, no, I think I finished. Um, okay, so last time I was deactivating and activating, but you don't have to deactivate the previous environment, I think, to jump into a new environment. So, so I'm just going to start. So without the password stuff, I'm going to start the Jupyter notebook. Um, okay, so you guys can see the Jupyter notebook, right? Um, okay, so let's create a new notebook. And because I use the environment variable in the same this window, same terminal where I started Jupyter Notebook, the environment variable being Google Cloud credentials. Um, so so let's okay. So I can I can install Google Cloud Storage. So I need to install Google Cloud Storage first. And the user is ready. The credential files are on in the user folder in my folder, home folder. So next step is to access. Well, Google Cloud Storage also has so many dependencies. So I guess yeah, I mean we had to do pip install, but if it was Conda, then the binaries would be already compiled, I guess. Okay, so this is still executing. Okay, so these commands, so let's focus on the next cell anyway. So we're calling from google.cloud storage object, and the storage object let's instantiate this object storage underscore client. I just gave a name ml underscore models underscore store, and then we're going to create a bucket with that name, and we're going to check what all buckets are there for us. I mean, when we do that, we'll need to get back this bucket name. So let's see. Yeah, it's finished installing. So okay, that name is not available. Okay, is bucket like a container? So yeah, a bucket is like a undefined, like a folder, but it's not exactly like a folder. You can think of it as a folder, but it's a container for data. Yeah. Uh, so it instantaneously created the bucket because of the credentials. So it has access to that project we have, and currently the bucket has a few. I mean, in terms of the buckets that we have, I have. I already had a bucket called Teja underscore model from before. This is the bucket I created. Okay. Now let's actually put something in the bucket. So you can see, actually this is a previous experiment. Um, so we're gonna put that. So we're gonna again connect, and then we're gonna create a blob, and then a blob is like, it's also like a folder. So no, actually a blob is like a file, but the file v1a would essentially correspond to the uh, uh, the file name for that blob will be this, and the sorry, the file name will be essentially v1a, and then the file itself will be uh, surprise underscore model, which is on my local disk. So let me get that on my local disk. This is a model that if you train the recommendation engine, then you can you'll get it. So you can see that I can do a $ls. So there is this surprise underscore model. This is a model that was dumped by the surprise package. It's essentially a pickle file, and then there is this is the credentials one, model and hyphen user, and then this is the metadata about the nodes. So let me run that. It will take some time to upload because I think the surprise uh, model is actually a 70 MB file. Okay, so actually now we can go back to our Google. So now actually I'm going to show you the UI based technique. So here, let's search for storage and go to storage. So here you can see that the bucket is there. It's like, as somebody said, it's like a container. And let's click on it. There is a folder called serverless. I just created a serverless folder. And there is a surprise model folder within which there are two files, essentially, v1a and v1b. So I should have used more, I guess, useful names, but v1a is the surprise underscore model, and v1b is the movie data metadata. So let me see. Just confirming for the flow, Conda on the VM. So last time what we did on VM, we're not touching the VM anymore because we're not talking about the VM. So this is like just a local. So wherever you want to have programmatic access. So where I installed Conda into my local computer only because I wanted to have a Jupyter. So I wanted to have a quick Python environment. But you can certainly do it on a VM, and then from that VM access GCP. You can do that. Okay, and that's actually the right way to do because why would you mess up your local system? But I was pressed on time. Okay, so we uploaded this. So we uploaded the models. So let's see next. Yeah, and we can also actually download the model, but I'm not gonna spend time on that. So now let's do the cloud function. for this model. Okay. So Cloud Function, we just did that before. So we have these files, okay, which typically will be model files. So let's again build a Cloud Function. Create function. Function one. Okay. This, okay, HTTP as the trigger type. There are various trigger types. Unauthenticated access just for development. I will save that. Oh, I wanted to change a few things. Memory allocated. I'm going to actually max out the memory to 2 GB. And timeout for the Cloud Function. So you'll see that because I have to load that 70 MB model file, and so you'll see the inefficiencies that I'm talking about. Because I have to load that file, it may take more time. So let me just make it 600 seconds, which is too much, but okay. Oh, that's too high. So let's make it 540. Okay, next. So now, again, we have to choose the runtime. Let's just Python 3.7. Entry. So let me just pick up the function from our okay. So I'm just copy pasting the model file. I mean, there is better ways to do it even programmatically, but so there's a little bit of efficiency that I'm trying to gain. So if you look at this script, it's very similar to our previous weather service script. Some entry point, let me change the entry point here. Recommend. Okay, so I'm also creating a global variable. So universally, it's generally not a good idea to create a global variable in Python. But for us, this global variable will allow us to not reload our predictions again and again and again. Okay. Actually, you'll see for the Lambda case, I'm actually just not even uploading the model, but just my predictions. But in this case, I'm just showing we have uploaded a model. We need a bunch of packages. We're going to specify them in the requirements file pretty soon. And a few functions which will help us, just these are helper functions. So let's come back to, and they're inside our, these functions are inside our, entry point function. Okay. So now let's come back here. So again, default to false, get the JSON, and as long as the user ID is in JSON, user ID is in the request, is in the post payload, then if you don't have that predictions, file, essentially it's a dictionary of lists or something like that, then you do a programmatic access. So here we are actually doing a programmatic access. Some of the screenshots I'm missing. Lambda. Yeah, so I'm gonna fix that. The AWS version. Okay. So the AWS version, actually, you'll see that the interface is very similar, but they have even a much more stringent space requirement, and they don't have requirements that text file. That's the only change. Pretty much everything else is similar. So I'll do that right after this. So what is the bucket name? Actually, I can use this previous bucket as well because it's the same. So what are we doing here programmatically? So we just set a bucket name. Again, we're creating a client, and we are getting to that bucket. And then we are defining the blob. We should know these paths. Okay. And then what we're doing is from that Google Cloud service, as a Google Cloud storage, we're downloading the model into a temp directory. So this serverless, I guess, server, option that is offering that is being provided, you can only dump, you have a function, but you don't have anywhere to read from disk and so on. So there's only a /temp directory where you can dump things, okay, where you can read and write. And so we're just reading from Google storage to a temp directory here, okay. So we downloaded that file. We downloaded the second file. Second file is just movie metadata to map from the movie numbers to the names. And then we are actually using pandas to read the movies data. You don't actually need pandas, but as you'll see in the AWS version, we're reading it. It essentially has three columns: the movie ID, the name, and the genre. We are making the ID the index, and we're also dropping. We're not dropping genre. Okay. Uh, Column, but and then we're loading the model and the predictions. Okay. Um, it, this is a little bit inefficient actually in hindsight, because we're actually creating the predictions for all users instead of doing it on a per user basis. So this is actually inefficient. This find the top K predictions for all users at the same time. Okay. Anyway, if you compute for all users, then for this user, which has been passed on through the JSON payload, you can just dig up, find the user in my top N, and just for each ID that I see, movie ID that I see, just tell me the name of the movie. So I'm just, that the name of the movie is in the data frame, so I'm just loading it from the data frame. Okay, so that's the pretty explanatory recommend function. That's the entry point. And in the requirements, I need to add something else. Where is it? Okay. So I need NumPy, Flask, okay, just to JSONify things. Pandas is actually not very necessary. Google Cloud Storage will be needed because we are actually using Google Cloud Storage to take the model file from there and put it in the temp directory here. Scikit surprise is needed. It can be eliminated, but is needed. Picklefy, because, and this is where I was talking about, why should we read the files from temp folder instead of the blob folders? I mean, you can read. So, okay, so that's a great question, actually. So why are we reading the file and again dumping to disk, right? So the ideal thing we should do is to read the file into memory, right? It's just like file open, file name, and it's just directly, or like pandas.csv, and then give the location, right? So the file is not publicly accessible, so we need credentials to access that file, for example, the model file. So here we are, again, being inefficient. We are reading that file and dumping it to a local directory. Okay. So is there a way to improve? Can we directly load that file into memory? That's a good question. It's a good exercise for you guys to find out as well. Great question. Another inefficiency that I wanted to point out was this. What is, I'm importing a specific package called pickle5. I know, so some of you already know this pickle is a Python package to serialize objects. Like if you have lists and dictionaries, if you dump to disk, and you can read from disk. Okay, but I'm using pickle5. So why is that? I'm using a special version of pickle. And that's because this is Python 3.7. I don't want to use Python 3.8 here, but my model was built in Python 3.8. Okay, so so there's some issue with serialization, and that's why I'm using pickle5 as a way to get around that. So you can see that there's a load function which uses pickle5 to load the model file rather than use pickle.load. Okay, so see, these are the issues that you find when from moving from development to a production infrastructure. Anyway, so we updated requirements, we updated main. So I think we just have to deploy. In the meantime, but that's a great question about why we're dumping it to disk in the temp folder. So it may take some time, because actually when it's creating it, there's a lot of requirement, a lot of I guess packages in the requirement, NumPy, pandas, and so on, which they themselves have a lot of dependencies. In the meantime, let me briefly mention a couple of more things before moving on to AWS, which is access management. So when I created this when I said create this function, this cloud function, I said unauthenticated access. So once this sets up, I can give you the link as well, and you guys can also query and get some predictions, right? For some fictitious user IDs. Um, but that's not good, right? If you have a like GPT-3, for example, is a text, is a language model, and if you it has like billions of parameters, and it's so even making a query to it would be expensive. So if you have developed GPT-3 or some model like that, you would not want it to have you would not want to have unauthenticated access. So you want to create some authentication mechanism, and Google services can let you do that, but I think it's something that you guys should explore. Um, the second thing is updating models, right? So right now, updating models. So on the cloud function side itself, once you have written the function of how to read a model and start serving, the serving part was completely behind the scenes being taken care of by Google platform, right? So the recommend function that we saw, it's not, it's less than 50 lines of code. So you can keep changing the you can keep creating such cloud functions and just change the blob from which you're reading the model. So that's one way to update the models. For example, maybe you're updating your model every week as users interact with your recommendation service. And so you have new data of the users, and therefore you'll train the model again and update the model, right? So you can keep doing that manually, or you can you can make the cloud function itself watch how many days has elapsed since you've been using a model, and then query for if there's a new model available on Google Cloud Storage, and then read from that model. Okay, so there are many ways to update your model and make the cloud function update your model. In the latter case, this example where I said the function itself searches for the latest model in Google Cloud Storage, there you don't have to create yet another cloud function, for example, right? So there are many ways, but different ways of updating have different pros and cons. So it's good to be acquainted with at least some ways to update your models. Okay, especially recommendation model that we're working with, it's very plausible that you will update it after some time to take into account the newer data that has arrived. Okay. It's taking a bit of time. Um, Actually, you can look at logs. Uh, okay, maybe it's not a log for this. Oh yeah, so the model is deployed. So now let's go test it. Um, so in this case, we have to give a UID. Uh, just to see if it's consistent, I'm going to give 206 because in my previous, in the notes, I have trained 206 as a user, but you can give any user there, and hopefully it works. Did I give 206? Yeah, Shawshank Redemption. Uh, Okay, so why is it taking so long? So you can see that there is a huge latency because the first time it runs, it's actually reading from Google's cloud storage and dumping into temporary folder, and then generating the recommendations. And it's actually generating recommendations for all users, although I'm only asking for user 206. So these are some improvements where you guys can pitch in and help me update. so so this is how you get uh, so the next. Oh, free variable df reference before assignment. Okay, let's see, where is that? Is that the case? Wow, even for deployment, there's so many errors. Ideally, you should not have such errors. Let's see. Okay. So if I do, it may be. I think I need to cache the errors better in that function. I'm not catching the errors, and sometimes, for example, keys are not found, like this user ID is not found, and so on. Will definitely be an issue. For even for this user, it's the same recommendation. Okay. So actually, you guys can try. I don't know. So if you can use Postman, if not, I'll just show you on Jupyter Notebook how to do it. That's the URL. Request um, request.get. Yes. Request of post. Sorry. Let me do this. Let me change this URL. And place it here. If any of you want to try, I'm posting it here as well. The JSON is UID. I don't know actually which users are available. So let's try this. And maybe we should try a couple of users. I think 206 works because that's something we tried before. Um, yeah. Well, the querying takes a long time. And okay, so one query went through fine. What happened in the second query? Let's query it again. I don't know. Actually, this one should have worked. That's fine. 0. Expecting value line 1. Where is it? Oh, okay. Json Decorator. I have no idea. Let's see. So was anybody able to try this query? This type of. So you just need to fire up Jupyter Notebook if you have access to it. Use this URL. Request. You may have it. If not, you have to $pip install or conda install. So this is how you would. I don't know what user IDs are available, but I thought 206 should work. So if somebody wants to try that, I'll keep it open for a few more minutes. But you should try the whole exercise. There's certainly a lot of fragility here and there that we need to fix in terms of coding, at least So okay, so these are the recommendations, and so you can imagine um, a different, like maybe on the front end itself, you would get this JSON as the input, and then you would clean it up, or call another API service, which will, let's say, for each of these movies, will get you the thumbnails and display to the user and so on. So that's how your model, which is serving a function, is going to interface with other services to get to your product, perform well in front of your users, right? So that's the process. Now I don't think we have time to get to Lambda functions. So, okay, maybe we can just do a hello world in Lambda. So Lambda, let's do hello world, because it just takes 5 minutes to set up a Lambda function to do, say, hello world. So Lambda functions are essentially the analog of cloud functions by AWS. So good thing about Lambda, I mean, it's basically very similar in terms of feature parity with respect to cloud functions. So let's start with, so if you log into AWS Management Console, you can go click services, and you'll see a lot of services. And I think last time some of you were asking how to get to EC2 and run an EC2 instance. You can just click on this, and starting an instance is very similar to what I did in that lecture with a different vendor. But let's do Lambda. Lambda is also falls under compute, because you're computing something. So let's click on that, and okay. So there is already something called model 2, but let's create a function from scratch. So in fact, author from scratch is a choice. Let's take author from scratch. This is hello world. Instead of Node.js, again, very similar to Cloud Functions, we're going to choose Python 3.8. That's the latest supported, and there are other things it's supported. See because you can already see a disparity, right? Python 3.8 is in beta for Cloud Functions, whereas it's doesn't seem like there's a beta type for this here. And you can just create the function. So in the meantime, anybody who wants to try with that URL to query a recommendation, let me write the query. Okay, so once I start, say, create cloud function, you'll see something like this, and then if you scroll down, you'll see a very similar setup, right? I mean, you have again essentially where you can paste your code, for example. But the thing that you'll notice is that there is no way to specify the requirements. So the requirements needed to run this function. If you have a package like pandas, you have to somehow get it yourself. So basically, this local folder has to set up the environment for accessing pandas. Okay, so that requires a little bit of complication. There is a way to again access S3. You can dump your model files and then the environment related packages here, pandas and so on, and then you can click upload from upload a file from AWS, generally a zip file, and then that will populate this Lambda function, and then you can run it that way. So I briefly describe that in the on the course page, but let's look at this one. So instead of a request, there's two different inputs to the. So this is like the entry point. Okay, so Lambda handler is going to be the entry point, and this event variable is the variable which will contain a payload. Okay, so if you want to pass a message or like UID or something like that, then the event variable will have that information. So so for now, let's actually, so we have this default hello world function, so we can actually test it. So let's click test. So let's give a name, test1, and you don't have to have this keys, but anyway, let's just create it. And let's click test. and test succeeded. And so because the function doesn't do anything, every time you call that function, it's just saying hello from Lambda. Right? That's what the function is. If you look down here, just return hello from Lambda as a JSON field. So this is what is returned. Okay. So that's good. So this hello world function works. Now, I mean, from internal testing. So you also, but for external testing, you want to do add one more thing, which is headers. Double check this. So I'm just trying to see how to specify the headers. Okay, that's okay. So let's add this line here. It's just a useful thing to, I mean, it's useful there. And so every time, so in the future, when we're going to create a model, serve a model, then the model will serve instead of dot dumps just a string, you can dump a prediction and so on. Okay. So we did this. Let's save this, and then what we're going to do is also add a external trigger. And so with this, we're going to be able to, and we're going to choose API gateway as a way to trigger this function. We're going to trigger this function using a HTTP request. Right? So for that, we need to have another object, which is API gateway service. So I'm going to create an API. We're going to create a HTTP API. And very similar to Cloud Functions, we're going to keep security open, which is unauthenticated, which is not a good idea in production. So let's do that. Okay, so we did that. Now the API gateway, yeah. So if we go to, oops. Okay, actually we can just use this, not that. Oh, yeah, so this is the URL. Oops, how did I get there? Okay, let's go back here. So I just added an API gateway. So we created a Lambda function, but there has to be something to get an argument to it, right? So the HTTP request you make, that URL endpoint is here, and this API gateway is the one which plugs back to this R Lambda function where computation happens. So this is a URL. I'm just posting in the chat, but and because it's a Hello World app, you don't really need any payload, and you can see it just works, right? And so you can set up the weather service. You can try setting up the weather service app on AWS Lambda, but as well as the model app. I mean, so most of the information is there on the course page. We'll try to repeat it if there's time next week. So any questions at this point? So let me summarize what did we do today. We spent the first part trying to revisit what we did in the first lecture, mostly about a new model that we were trying to use today, which is a recommendation system model, and then about model persistence, how Flask-based deployments can be need a lot of DevOps work essentially. Then we switched gears and we talked initially a little bit about managed services, and then we jumped right into jumped right into it by starting to work with Cloud Functions, which is provided by Google Cloud Platform. And we actually installed Google Cloud as a command line utility and created an S3 bucket, sorry, not S3, but a Google Storage bucket in which we dumped our model files. And then we created a Cloud function from there, which we could read the model files and make predictions. In between, we also created a service account for to this programmatic access from our local machine. The service account is not needed for like within the cloud function to access S3. Um, so that's what we did, and then the last part we just looked at the hello world example Lambda function from AWS. And so if there's time next time, we'll look at both the weather service as well as the recommendation prediction model. And in the course, there were several inefficiency aspects that were brought up by some of you. So it'd be great if we can fix them and improve the docs. So you can do a pull request if you're ambitious, or you can just let me know through Slack, and we can improve the codes. So if there are no questions, then we'll stop here. I'll stop the recording. And yeah, I'll see you guys